Hello Akshay, good evening. Hello everyone, welcome to the class. So today is basically your third class in the for the physical world and measurement. This is basically going to be a third class. Actually, for the measurement topic, this is the third class. So once again, before I begin, my name is Mohana. I'm a physics educator at Unacademy. I'll be taking your class 11 and 12 physics, and you can actually join me in my Telegram channel. So before going live, I'll be sharing the Telegram channel link in the group. Okay, and all other updates can also be found. Now, similar to my Telegram channel, there is also one more channel that is the common ICSC, Unacademy, ICSC and ISC board channel. You can actually follow this channel as well. And just like how we have free classes on the YouTube platform, we also have classes on the Unacademy site itself, right? In the Unacademy platform itself, we have some free classes. So these classes are absolutely free. You can take any of your favorite educators' classes here. And one of the interesting features is that the classes have a pool feature, so you can learn a concept and there'll be some question asked based on the concept that you learned or any questions, right? So you can answer those questions through pools, right? And you can assess whether you've understood the topic or not. Now, they would be, because these classes are again live classes, they would be doubt clearing sessions as well. Okay, now for the special class on Unacademy platform, there is one class on 30th May at 4 p.m. Okay, the topic we would be discussing would be from your dynamics chapter 3. So you can join this class, but to join this class, you're going to use my code MTIS10. You can use this code to unlock this class. You can join this class, and on 30th May, we will discuss some topics from here. Alright, and at Unacademy again, we also have the plus class subscriptions. In case you're taking the plus subscriptions, you can the advantages are you can learn from the comfort of your home, right? You have unlimited access to all the courses, and you will be learning from top educators. And also every fourth class, right? If today we are starting a session, the fourth class from today, every fourth class is a doubt clearing session. Okay, every fourth session is a doubt clearing session. So whatever you've learned in the previous classes, you can actually clear those doubts based on those topics. You can actually ask any doubts you have based on those topics in this session, and you can clear your doubts. Now, we would be in plus subscription, right? Plus classes, we will be covering your entire syllabus, right? And we also have live test series. So every weekend, we will be having one live test series. You can take the test to assess whether you understood the concept or not. And in case when you're taking after the test, there would also be an analysis session. So in case if you're making any mistakes, or you don't know how to solve a question, or you want to know how to solve the question better, you can ask the educators on how to do the same. Okay, and we are always coming up with new batches and courses, so do check out. Now, before we go ahead, the pricing for the courses, if you're taking a longer duration, the price for the course actually comes down. So, in case if you're in class 11, you can take subscription up to class 12 as well. So, if you're taking 2 years of subscription, then the price value comes down. Okay, and on top of that, if you're using, right, then on top of that, if you're using my code MTIS10, then you will be getting a 10% discount on any course that you're taking. Any duration of the course that you're taking, you'll be getting a 10% discount if you're using this code. Other than this, we also have the Unacademy National Scholarship Admission Test that is going to be held on June 4th and 5th. So the last days to register is June 2nd. The price of each course is around, I think the registration price is around 199 rupees only. And if you're using my code, right, MTIS10, you can get a 10% discount on the same. Okay, so all the tests, this particular UNSAT is basically going to be an offline test. I mean, it is a computer-based test, but it will be an offline test. The test will be organized around 40 cities, and all the test takers will get get an Unacademy T-shirt, and the top 40 rank holders will get iPhone. And the scholarship is, you can actually get up to 90% scholarship. Okay, from Unacademy centers and also for online subscriptions. Alright, this course is just going to, the registration is on June 2nd and the test is going to be held on June 4th and 5th. So do register, right? It's so this course, this test is for IIT JEE, NEET UG, and class 9 and 10 fundamental basic, the foundation courses. This is for aspirants who want to take your IIT JEE, NEET UG, or class 9 10 if in case you're taking the fundamental course. So if you're going to take your NEET or IIT JEE exam this academic year, no, towards 2023 or the year after that, and in case of 9th and 10th standard, you have around 2 to 3 years, right? All of you guys can actually take up this course. Alright, now a quick recap before we go ahead. Any doubts you have about this, you can actually drop me in the chat box. About ANSAT, you can drop in the chat box. Now quick recap about what we have been doing. We've started studying about physical quantities, right? Any quantities you can directly or indirectly measure is called as a physical quantity. And there are two types of physical quantities. One is the fundamental quantities, another is the derived quantities. Fundamental quantities, they are independent of other quantities, okay? And they cannot be defined in terms of other quantities. For example, your mass, length, time. But then a derived quantity is basically defined from your fundamental quantity. Example, force. Mass into acceleration gives you force. Acceleration itself is given by velocity by rate of change of velocity with time. Velocity again is defined as distance by time, which is a fundamental quantity. So derived quantities are obtained from fundamental quantities. Okay. Now all of these fundamental quantities and derived quantities has an associated unit with them. Okay. And in this and then we learnt about the system of units. There are different system of units. So if you know about the different system of units, you can actually give it in the chat box. Right, Akshay. CGS is right. FPS, that's correct. MKS, that's right. And what is the one we usually use? What is the system of unit we usually use? The internationally accepted system of unit that we are following from 1960 onwards has been the SI system of units. Right, Akshay, that's right, the SI system of units. Last class we have extensively covered it. So I guess I can go ahead, right? Now, the SI system of unit has 7 fundamental quantities and 2 supplementary quantities. Can you tell me the 7 fundamental quantities? What are 7 fundamental quantities in the SI system of units? Length, that's right. Correct. Unit of length in SI system of unit, temperature, that is right. Right, length over here is given in terms of amount of substance, that's also correct. Luminescence intensity, that is also right. Okay, so length is basically given by the unit of meters, right? Length is given in terms of meters and the symbol we use is m. Mass is given in terms of kilograms and the unit we give is kg, right? Correct. Now the next is correct. Time is given. What is the unit of time? Second, that's right. So the symbol used is S. Okay. Next, current, electric current. What is the unit of electric current? Right, amperes, and the symbol we use is A. Right, good job, Akshay. The next one is basically temperature. Temperature is given in terms of Kelvin, right, symbol is K. And then amount of substance, this is mostly you will use in chemistry. Amount of substance is basically given by Mole, that's right, and the symbol is MOL, right? And that's correct, Akshay. And the next one is luminous intensity. This talks about the brightness of light, right? So luminous intensity is given by candela, right? We use CD as the symbol. Okay, these are about your, good job Akshay, these are about your SI system of unit, these are your basic units. What about the two supplementary units? What is the name of the two supplementary units? Right, so radian actually measures, radian is the unit. What does it measure? What is the physical quantity that it measures? Radian and steradium is correct. Radium and steradium, steradian is correct, but what does they measure? So they are actually measuring angle, right? So radian is a measure of plane angle. Steradian is a measure of solid angle. Radian, again, we give it as RAD, right? Radian is given as RAD, symbol RAD, right? Radian to indicate radian, and steradian, steradian is given by SR. Okay. Right. These we covered in the last class. Now, today's class, let's look into the measurement of length. How do we measure length? Okay. So, right, Akshay, that's right. We'll see how to measure length. There are two ways in which you can measure length. One is by direct means. Okay. So, what are the measurements you can take by direct means? So, if you basically use a scale to measure, that's basically a direct measurement. Okay. If I want to know what is the size of this particular pen, right, I will take a scale to measure, right? That's a direct measurement. Okay. So the instrument you can use to measure by direct measurement would basically be your vernier caliper. Right? Can you name any other instrument that is used for measurement? Scale is right. Actually, if you're using a thread, and again, if you have to measure what is the length of the thread, right? If I use a thread, actually, if you're using a thread, I'm sorry, just give me 1 second. Right. So if you're using basically a thread, and if I use a thread to measure this, right, then again I have to measure the thread also. So Asher, hello. Okay. So other than vernier caliper, any other device that you've used in your grade 10? Any other instrument you've used for measurement in your labs? A measuring tape, okay, right, that also you can use. A measuring wheel, okay. Ashur, the books we are basically referring to is given down in the slide itself, right? I'll be referring, the reference book I'll be using is from your Newton, and also your all the prescribed reference books for ISC syllabus I would be using. One is basically a Newton, another one that is given is your SL Aurora. That is your New Simplified Physics. Does that answer your question? Okay, you can use vernier caliper and you can use screw gauge. Okay, vernier caliper is very simple. Now, if I use a scale, right? If I use a scale to measure the measure this particular, you know, if I want to know what is the length of my pen, I want to measure using a scale. I'll get the value somewhere around 13.4, 13.5, right? I'll get only up to 1 decimal point value. If I want more than that, if I want a value more than that, okay, I want up to 2 decimal point value. I want my accuracy to be more than that. Okay, in that case, what will I do? I'll go with the vernier caliper. Why? Vernier caliper has a fixed scale. All of you might have seen a vernier caliper, right? Yes, Sasha, least count is 0.01 for a vernier caliper. That's right. So, so you can measure up to, like if this, whatever the pen length is, this pen length is, if it is 13.4 using a vernier caliper, I can find it using one more division I can find. Okay, so vernier caliper, basically in this case it has two scales. One is a main scale and then it has a movable scale or a vernier scale. Okay, now how do we find the least count of a scale, right? How do we find the least count? The least count of the scale is basically, it basically depends on the value of one main scale division by number of divisions on the vernier scale. Yes, Akshay, something like up to 2 decimal point values, that is around 13.45, as Ashur is saying. That's right. So number of divisions on the vernier scale, right? So how many value of one main scale division? One main scale division on the vernier scale is 1 millimeter. The number of divisions on the vernier scale is 10. So you will get the least count of up to 0.01 centimeters. Okay, so that's the accuracy to which I can measure using a vernier caliper. What happens in case of a screw gauge? What will happen? What will be my least count of a screw gauge? Screw gauge uses the principle of screw. Okay, one has a fixed scale, another scale you can actually rotate. So screw gauge least count is given by pitch of a screw, right? By the total number of divisions on the head scale. You have a pitch scale and a head scale. And Ashur is saying 0.001 centimeters. 0.001 centimeters. Your units again are important. In case of a screw gauge, the least count being 0.001 centimeters. This is important. Okay, so that's the least count of your screw gauge. Okay, so these are measurements. Now using screw gauge, if I'm measuring if any size that I'm measuring, any values I want, I will get up to 3 decimal points in terms of centimeters. Okay, so this is about the direct measurements. Okay, now what if I want to measure, let's say opposite to you there is yes, Akshay, you can measure any thickness or the diameter of a wire using a screw gauge, right? Now the screw gauge least count is very simple. It will be the pitch of the screw. Pitch of a screw will be 1 mm. And the total number of divisions, 100 divisions will be there. So you get 0.001 centimeters. Now, in case, let's say I want to measure, okay, this is very easy to measure, no? If I want to measure what is the height of a mountain or what is the height of a building, okay, what would I do? In that case, I cannot go in for direct measurements. In cases like those, I go in, or I want to measure what is the distance between the earth to sun. So these cases, okay, let's say a bird is flying in the sky. I want to know at what height it is flying. For these, we cannot do a direct measurement, right? In these cases, what do we use? Right, we use indirect measurements. In indirect measurements, we make use of trigonometry, right? So, in indirect measurements, there are 2 ways in which you can measure anything. One method is basically your reflection or echo method. Okay, this is one method. Okay, so second method is basically your triangulation method. Okay, today's class will cover about this indirect measurements. All right, so reflection or echo method is very simple. Okay, so let's say there is a hill over here. Okay, now what you do, you send a from a point, okay, you send a sound, right, from one particular point, right? This is your source of sound, any sound or source of sound. Okay, we know how many of you have tried, usually when you go and try to scream something, right, your echo is sometimes heard, right? So here what happens, similarly you use a sound, okay, and you direct the sound this way, the sound hits the hill, this is the original sound, okay, and as it hits the hill, again it will get reflected back towards you, right? It bounces back or it's reflected back towards you. This is the reflected sound. Okay. Now knowing these two measurements, I can actually find what is the distance from my point to that hill. What is the distance actually I can find? Right? How do you think we can find that? What formula can we make use of in this case to find the distance? We want to see, this is your source of sound, this is where you are. Let's say this is where you are, and this is where the hill is. What formula can you use to find the distance? Right, we can make use of that. Actually, could you explain that formula a little bit more if you can? Right. So let's say you have a gun and you're firing the gun. Okay. As soon as the gun is fired, okay, let's say for it to travel this distance, right, it travels the original sound, right, and for it to get reflected back, for it to travel the original sound and for it to go hit the hill and come back, let's say it takes a time t. Let's say for that case the time taken is t. Okay. Now what is the total distance? Let's say in one way the distance, this one side, the distance is d. So if it goes, hits and it comes back, so the distance in this case is 2d. Alright. Now we know velocity is nothing but what? Velocity is nothing but distance by time. So if I want if I want the distance, right? If I want what is my distance will nothing be velocity into time. Okay. Now so here my distance is, in this case the actual distance is what? The speed of the gun, right? The speed, if you're firing a gun, right? So the speed has, the sound waves has to travel, hit and come back. So the distance is twice, right? 2d. So in this case the distance is 2d. Okay. So d, that is right, Akshay, as the sound hits and then bounced back, so it is divided by 2. That is right, Akshay. So this is basically v into t divided by 2. So if we know v, if we know the time t, we can find the distance. Now this is the main principle that is used in sonar, okay, and basically your laser, and also in radar. All three uses the same principle. Okay. Anybody know what is the full form of sonar? Or the full form of laser? Sound navigation and ranging, Akshay, that's right. So sonar right? Sonar is basically sound navigation and ranging, right? And where is this used? Where is sonar used? When will we have the next special class on Unacademy? On 30th, Asher? Right? Yes. So basically you can see this application of the sonar in terms of anything that is happening under seas, underwater, right? Basically, if you want to see, it is used for to detect object submerged underwater, similar something like, you know, your sea rocks or submarines. Okay, and this is for measuring their depth. In this case, ultrasonic waves are used. In case of sonar, ultrasonic waves are used to transmit to basically these waves for transmitting or sent into ultrasonic waves are it is basically submarines or tank. That is right. Okay, in this case the sound waves are used, that here are ultrasonic waves. Ultrasonic waves has a frequency of about 20,000 hertz, so we can't hear it. All right. So basically, when this waves, right, ultrasonic waves, they hit any rock or submarines, they are reflected back, and that is getting detected by this by a detector in the sonar. Okay. Now, if you measure the time interval between the transmission and the reception, okay, and if you know the speed, and if you know the speed of that sound wave, that ultrasonic sound wave that is going, right, then you will get then you can actually find the depth in which the rock or submarine can actually be calculated. Arjun, good afternoon. Okay, so this is in case of sonar. So what about laser? What about laser? What is the full form for laser? Laser actually stands for light, right? Light amplification. Light amplification. That's right, Akshay. Light amplification by stimulated emission of radiation. Can you tell me some of the properties of lasers? What are the properties of lasers? Okay, the laser that is produced, it's basically a very intense. They are highly monochromatic. Monochromatic means they have one single wavelength, meaning they are just single colors. Okay, and they are unidirectional beam. What does the meaning of unidirectional mean? Lasers are again unidirectional beam. They are unidirectional, meaning for a very large distances they go without getting deviated. So they travel in a straight line path. So if you see astronomical telescope that we're using, we use this very strong laser to point it towards the sun, towards the star to which you want to align and watch. Okay, and right. So also so this laser beams, right, it allows us to measure even up to large distances. Okay, you can actually measure distance from moon to distance of moon from earth even using the laser. Here what happens, you send the laser beam, right, from you transmit the laser beam from earth to the moon, right, which were the object you're taking, right. This laser beam will get reflected and come back towards the earth again. Right. Now, if you know the time taken for the laser beam to go hit and come back, and if you know the speed in which it is going, right, then obviously you can actually actually find what is the distance. Now, the speed in this case, right, in case of lasers, if you're seeing, the distance you want to find is basically depends on the speed in which it is traveling into time divided by 2, right, because this distance is twice. So this c over here is nothing but this c in this case is in the speed of light, right? The laser is basically light. So c is basically in this case it is 3 into speed of light, right? Laser has this the speed of this light will be 10 to the power of 8 meter per second. So if you just know the time taken, then you can actually find the distance. So this is by using laser method. Okay. Now, what will be in case of, we have till now seen for solar and laser, right? What will be in case of radar? How would it work in case of radar? Radar, what is the abbreviation of radar? Okay, radar stands for radio detection and ranging. Okay, so here radio waves are made use. So in case if you want to see how fast in what height an aeroplane is going, what do? We make use of the radio waves. The radio waves are transmitted. Okay, so as soon as the radio wave hits the airplane, what happens? These waves would be reflected back. Okay, the reflected the rays that are reflected back are again taken basically are again detected by a detector. Okay, Akshay, what is the radio detection and ranging is right, and in this case right, we use radio waves to find the distance of object. That is right. In this case again, the distance you want to find, d, is basically given by what? Velocity, right? But in this case, what is the velocity? In this case, we are talking about a radio wave, right? That travels at the speed of light, correct? So in this case, again, the distance you want will be the speed of light, right? The speed of the radio waves times time. What is the time it takes for it to go hit the airplane and come bounce back? By 2, right? So in this case, the speed in this case, c, is given as what? 3.0 into 10 to the power of 8 meter per second. So that is c, right? So using this method, okay, using the echo reflection method is what is the basic principle of your radar, your laser, and your sonar. Okay, now this is one method of this is basically one type of your indirect measurements, right? Now what will be the other type? The other type is basically the triangulation method. Now triangulation method basically makes use of trigonometry. Let's say there is a tall building, or in our case, let's say there is a tree. So we are if the picture is too small, but if you are actually here, we might just be in this size when compared to this tree, right? Now if I want to measure the tree, right, what do? We have to make use of trigonometry in this case. And what we are going to do is, we are going to come a certain distance away from the tree. We are going to walk certain distance away from the tree. And what we are going to do, now this distance can be measured, right? We can actually measure this distance. And that's right, Akshay, you're giving the answer, that's correct. So this distance we can measure. Let's say this distance is x, okay? Let this be a, and from the point that we are measuring, let this be. Alright, so this is your method for triangulation here. Okay, here it is very simple. Now, this is a right angle triangle, right? We have P, B, A and B. Now, what are the two sides we want? Which angle will we be using? Akshay, you're giving me cos and tan. Which angle? In this case, I want to find the height. I want to find the height of this of the tree over here. Which angle can I make use of? Tan, that's right, because tan theta, okay, now tan theta will give me opposite, that is basically AB, by adjacent. Adjacent is basically this distance PA from a point of observation to this to the base of the tree, right? Right, perpendicular upon base, right? So over here, AB is nothing but height, right? You have the height by what is the base? P, this space distance. This distance can be measured from here to here. We can measure the distance, right? That is x. From here, we can find what is the height of the tree. H will be x into tan theta. That's it. That gives you the height of the tree. Okay. In case, in the same triangulation method, in case if this distance, right? What if we cannot measure this distance? This x distance. Let's say you see a far away mountain, okay, and you're like kilometers away, and you cannot measure how many kilometers it is. You can't keep measuring. You don't know how to do that. Okay, very far away. In that case, what do we do? Okay, in such a case, what we do is, let's say this is the height of the object we want to measure. Let's say this is a mountain that we want to measure. This is again AB. Okay, this is the height we want to find. So what we do, a little distance from this. Okay, so what we have to do is, from the point of observation at one point, what we are going to do is, we are going to measure what is the height of the mountain from the peak. Okay, we are going to measure this angle. Let this angle be theta 1. Okay, after that we are going to move back some more distance, right? We are going to move back. The reflection in this case not really Akshay, because now we are looking into how to measure the height of the mountain. No, we're not trying the distance. Okay, the reflection that the echo method we used, we gave us this distance, that is basically this distance x from us, how much far away it is. Now what we want is this height h, this distance, right? For this we make use of triangulation method. Okay, now what we want is the h over here. Now also, now this now what we can do from this point, right, from this point wherever we are, we can move back a little. Okay, we can go a certain distance. Let's stand in another observation part Q. Right, we're getting two right angle triangles, that's right. Okay, and we can measure this angle over here. You can use a device to measure the angle over here. That is x2. This kilometers can be kilometers away. That's, you may not be able to measure this, but from P to Q you can actually measure this distance. Let's say that distance is basically x. Okay, now what happens in this case? You have two triangles, right? Right. So okay, so that's okay. So from here what we can do, two angles. How do we measure both the angles? Very simple, right? Tan of theta 1 is what? This is basically tan of theta 1 will be h, right? Opposite h by this side. We don't know what that length of that side is. That is p. Okay. Now again, tan of theta 2 is what? Now this is basically h divided by whatever this value is. What is this value over here? H divided by this entire value QA. Okay, this entire length that we are taking QA. Now this length QA that we are going to take, this QA is basically QP plus PA, right? So from here we can get what is PA. PA is nothing but H into H by tan theta. H by tan theta, what is the inverse of tan theta? 1 by tan theta is equal to what? Right, 1 by cot, that's right, 1 by tan theta is equal to cot. So you get this as H cot theta 1. Okay, now over here, similarly, QA from here, you want QA will be what? This will be H tan theta 2 comes down here, it will be cot theta 2. Right, now this QA, this entire QA is equal to what? QA is nothing but QP, this is a distance we know, that is x, plus PA. This is basically your QA. Right? What is x over here? QP over here, x. Plus what is PA? PA is something we already know. This is basically H cot theta 1. Right? Now all of this, right? All of this. We know these values. This is equal to what? This is equal to H QA. QA is H cot theta 2. From here if you want H, I'm sorry, sorry about that. Okay, from here if I want x, right, from here if I'm measuring x, will be H, this will be H cot theta 2 minus H cot theta 1. From this entire equation, if I want height, I can take the H common outside, right, and it will be cot theta by, actually that's correct, H into cot theta minus H cot theta 1, that is right. Okay, so from here if I want H, right, if I want to find the height, now this height H of this building or the mountain, whatever we want to find, that height H will be equal to basically be equal to x divided by cot of theta 2 minus cot of theta 1. So if you know theta 1, theta 2, these two quantities you can measure, and if you know the x, that also you can measure, you can find height of the object that you're taking. Okay, so this is your second method, that is your triangulation method. Okay, using this you can find the height of any object on earth, right? What if we want to go still further, right? Then we make use of, if you want to measure object, okay, measurement of size of any astronomical object. If I want to measure what is the diameter of a moon, how do we do that from here? Okay, we can actually use the triangulation method here. Okay, light year, actually light year is basically the distance traveled by light in vacuum in 1 year. Okay, so yeah, you can, but you can actually make use of a very simpler method than that as well. If I want to find the okay, the diameter of the moon, right? So I have a moon, I want to find this diameter, right? How can I find the diameter of a moon? So this is measuring the size. This is a measurement of size of astronomical object. Okay, this is the measurement of size of astronomical object. This is measurement of size of astronomical object. And now we want to find what is the diameter of the moon. And we are on Earth, right? So we are here. We are on Earth, right? And from this point over here, we want to measure, okay? We can actually use the triangulation method only to measure the diameter of the planet, right? In this case, the diameter of the moon. Okay. If you look at a telescope, the image of the moon will actually appear as a disk, right? Now, now what we can do is from this point of observation on Earth, right? Again, same triangulation method. That's right. We can take this distance, right? And from this side, we can take this distance. Okay, let me just do that a little bit properly. From this point, no, these two distances that we are taking, this gives you the height h, this height, this distance, this is d. Now this d can be measured from here to here. As you said, you can use any of the reflection methods to measure d, right? This is the distance from the point towards this moon. What is the distance, right? That you can be measured. Okay, now this d gives us the diameter, the moon's diameter from Earth, right? This gives you the diameter. We want to make the diameter. Now this again forms an angle, right? This angle is actually theta. Okay, now this angle theta is suspended around the diameter. Let's say the diameter of the moon is AB. Okay, from wherever you're measuring this, from this point, the diameter of the moon is AB, and you have an angle theta. Okay, so D is basically like a linear diameter of the moon. Okay, and S is the D is the distance from the point of from Earth to moon. Right. So because the distances are also very large, instead of you can avoid that, you can think of this as a straight line. Okay, so this would basically be till this point over here, right? This is your distance. So you can, to find the distance, you use any one of the triangulation methods. Now, how do we get this distance d? The theta will be given. This theta that you're getting will be in radian. Now you can actually make use of instead of now you can make use of plane angle, right? Theta that you're measuring will be in radian. Okay, this will be so this will be, theta will be this distance times this by this arc length, right? The length to that of the radius of the circle to that of the arc length. In this case, the arc length that we are considering is basically d. By what is this length over here, this radius from the center, that is your solid angle, right? If you have a circle, and if I want to find a very small portion of the circle, and if I want to find, right, let's say the angle suspended, let's say from the center to this point, this distance is r, this distance is r, and say this length of the arc is L. So if you want my solid angle, this is in terms of radian, the solid angle is basically given as, this theta is given by length of the arc L by the radius, right? The radius in this case is r. So that gives you the solid angle, right? We are using the same concept. Here d, diameter, distance d is taken, right? From here, we want to find out what is the distance from here to here, this distance, right? This is basically d, both sides it's d, right? D we can find, the distance from Earth to moon. You can use triangulation method to find. So that is basically given by d. Okay, some books takes the distance d as s also, That is also right. In my case, in this case, I've taken it as D. Okay, so from here, right, theta is very small. Okay, so theta is also very small, and okay, this diameter that we are taking, we are thinking of that as an arc of a circle. Right, from here, if I want to find what is the diameter D over here, this diameter D is actually equal to theta into this. Okay, let me not confuse. The small d I'm talking about is basically the distance. Okay, into D. So that gives you the diameter of the moon. If you know this distance, triangulation method, right, and if you know the theta, which can be measured, okay, then you can actually find the size or the diameter, the size of the moon. Okay, but we can't use this method to calculate the diameter of stars, because stars appear in your telescope as point objects, right? It basically applies because they are so distant from us, they appear as points. So you can't use this to calculate the diameter of the star, but you can use this method to calculate diameter of the moon. Clear? Alright, can I move ahead with the next concept? Alright, good, great. Okay, let's go on. Now, what if I want to measure a distant star, if I want to measure the distance of any astronomical object. I'm seeing a star in the night sky and I want to measure how far away it is. Then the effect we would be using is basically then the method we'll be using is a parallax method. Okay, parallax method just gives you the apparent shift in the position of the object. If you want to actually experience parallax, it's very easy. Okay, just hold a pen or any object that's little far away from you. Close one eyes and make sure this object that you're keeping is in reference to some other object in the background. Okay, and close one eye and see where is this object. Now close the other eye, right, left eye, right. Now close your right eye and see. There would be a distance, right. First you would think, okay, let's say there is a background, let's say there is a lamp. Okay, I'm holding my pen with reference to this lamp. So when you close your right eye, when you close your left eye, the pen might occur somewhere over here, right. When you close your left eye, the pen will basically will look somewhere over here. Now actually where it is over here, but when I close my eyes, it looks in two different positions, right. Now there is a shift in its position. This apparent shift in position is basically what we call as your parallax. Okay, now this again it is again use again to measure parallax, right. It is measured by the distance, by the angle between the two line of sights. Okay, so you can make use of parallax method to actually find the distance of a distant star as well. Okay, very simple. Let's say the Earth goes around the sun, right? The orbit is elliptical, but we'll just take this, and its sun is at one of the foci, but it's okay. We'll just take the sun as in the center for this one. Okay, so we're going to see a star. Okay, this particular star is fixed in the night sky. All right, so wherever we are, wherever in the 365 phase, wherever we are in this orbit, the star looks fixed for us. Okay, now what happened in one particular month? Okay, let's say any particular date, that one particular month when the Earth was somewhere around December, let's say around December, when Earth was somewhere in this part of the orbit. Okay, let's mark that position as A. We are observing the star. Okay, so this star right now we are looking at the star, but we are looking at the star based on some other star that is further away from here. Okay, some other star is in the background also, but this star we know it is always fixed. So this so we keep it. We measure this particular star. Okay, now Okay, now what we're going to do is basically, let's say this particular star is moving. So there's a star over here. Okay, now this particular star is let's give the position as north. So what happens, wherever we are in this orbit, this particular star, right, appears as if it is straight. When we are watching, it appears straight. It is actually moving, but it's moving in such a way that wherever we are on this object, this particular star appears straight. Okay, now similarly, after by December, right, again by June when we are on the other end of the orbit. Okay, let's mark this as B, right. This star which always appears whichever month, wherever we are, this just appears straight to us. Okay, this star will be somewhere over here. Alright, now if I want to measure this distance, right, now this gives me an angle. Right, now if I draw a line joining these two, now this gives me an angle phi 1 and this gives me an angle phi 2. Right, so if I suspend this, if I'm drawing a center arc line over here, this angle is phi 1, so this angle will be phi 1, this angle is phi 2, so this angle will be phi 2 again. The entire angle we are taking is phi. Okay, but what is the distance from the earth to the sun? Distance from earth to sun, right? What do we call that as? What do we call that unit as? Akshay, what happened? This north star, right? This north star, wherever we are on its orbit, it just appears straight towards us. Okay, and this star S is, we have just chosen the star, we want to measure how far away that is. Okay, so in that case, we measure this distance of star and we measure this distance, we get this angle phi 1. Similarly, this side we have another distance, this side when we are after 6 months, we measure this phi 2. Now both these angles together give me phi. This angle phi is basically your parallax angle. Okay, now from here, right, correct, from this point A to the sun, that is over here, this is 1 astronomical unit. From here to here, this is another astronomical unit. Okay, now if you want to measure the distance of the star, how do we measure the distance in this case? This distance of the star, okay, this distance of the star, this is S, right? This distance of star is S, this distance of star is basically S again over here. Right, if I want to measure this S, the distance to the star, then what we will do, we will use then we will use this parallax angle, right? This parallax angle phi is equal to AB, right? This whole length AB by this whole length AB by this distance, just the solid angle as the solid angle that we did before, AB by S. Okay, now AB is what? Basically you can take this AB, this distance you can take as 2 astronomical units, right? This unit, one astronomical, this from here to here is 1 astronomical unit, from here to here is another astronomical unit. Okay, so this you can actually take it as B, the entire length from here to here you can take it basically as B, just 2 astronomical unit. So this will be B by S. Right, so from here, if I want to find this distance to the star S, that will be B by phi. Okay, so B being the diameter of the Earth's orbit around the sun, B is just 2 astronomical units, that's it. Okay, then we measuring phi in terms of radians, and also from here we can find S. So this method you cannot use for stars that are more than 100 light years away. Why? When you do this, this angle phi becomes very small. For very distant stars, the angle phi becomes very small and then phi will be equal to 0. In such cases, we can't use this method. We go for spectroscopical methods to measure, to find the distances of such stars. Alright. So this is about the distances method we covered till now. So if you have any doubts, you can ask me in the comment section right now. And once again, the plus batches, So class 11 plus batches in Unacademy website, right, in Unacademy platform will start from 8th June onwards. If you're planning to take a subscription, this would be the best time to take the subscription. I would be taking physics, Jyoti ma'am will handle math, Manisha ma'am will handle chemistry, and Lakshay sir will take biology. So we would be meeting every Tuesday, Thursday and Saturday between 5:15 to 6:15 p.m. Okay. Focus of this plus batch is your term 1 syllabus coverage. So we will start with physical world and measurements, and we will go on and complete the first 5 chapters, first 5 units. Okay. So that's the focus. And again, UNSAT, Unacademy's National Scholarship Admission Test. If you're planning to take the test, you can actually register in the website, right, in the UNSAT website, right, and you can actually win up to 90% scholarships, right, for Unacademy centers and also for online subscriptions. And top 40 rankers will win up to we can win an iPhone, right, up to 40 rankers can win an iPhone, and all the test takers can get an Unacademy t-shirt as well. The registration process is till June 2nd, and the test itself happens between June 4th to 5th. This test is for the aspirants who are preparing for IIT JEE, NEET UG. Okay, we're going to take your NEET or IIT JEE this 2023 and the coming years. Okay, as well as this test is also for class 9 and 10 students who want to take foundation courses. It is a computer based test, but it will happen in the offline centers. So the test is happening around 40 cities, okay, around in India. Then again, this test for registration costs around 199 rupees. If you're using my code MTIS10, you'll be getting a 10% discount. So somewhere around 170 rupees you'll be paying for the test if you're using an educator's code. So you can use my code to avail the discount in case you're planning to register. And again, Unacademy community is one more feature where you can follow any of your favorite educators community and you will not miss any updates from them. Okay, and also my community link is basically shared over here. And Bucks Bounty is one more app the Unacademy team has come up with. Again, not an app, sorry, is one more, is basically if you're seeing any inappropriate content in any videos, and if you're actually reporting those inappropriate content, if you file a report against it, then the Unacademy team will basically give you your prize. Okay, so subscribe to the channel, click on the bell icon to subscribe to the channel so that you stay tuned to all the upcoming classes, and also like and share the class, right? So the next class, again tomorrow morning we have one class around 10 o'clock, and also tomorrow evening around 4 o'clock we have one more class. Okay, so with that I'll see you in the next class. Thank you.